Good morning, students. So we have seen some small introduction about what is random process in the previous classes. And in specific, according to our syllabus, we have Markov process. So Markov process is a random process first, whose past has no influence in the future. Okay. If present is specified. As I said in the previous classes, so the future only depends on the present value. It does not depend on the past values. Okay, so we said that probability of x of tn is equal to an, provided x of tn minus 1 is equal to an minus 1, etc. x of tn minus 2 is equal to an minus 2, etc., etc., etc. The beginning t naught is equal to a naught. So this is the future value and this is the present value. So it does not bother about all the past values. So we can simply write it as P of x tn is equal to an. It only depends on the present value. So this is called as Markov's process. Then we see four kinds of process, sequences, everything. Okay. So now we are going to deal with Markov chain. If for all n, probability of xn is equal to an and xn minus 1 is equal to an minus 1, etc. x naught equal to a naught, then the same actually xn equal to an, the future depends only on the past values an minus 1. Okay, so then the process xn is called as Markov chain. This a naught, a1, a2, etc. an are the states. Okay, states of Markov. So when we start problem, it will be very interesting. We're going to start now. Then this is Markov chain. The other properties I will explain in problem point of view. Okay. So now when we go for problem point of view, I just explain what are all the terminologies we are going to use in the problem, student. Just watch this carefully so that any problem you can easily crack out. Okay. So now here we are going to deal three things. We are going to find in this problem pure probability. The second one is conditional probability. And finally, we are going to find sequence of probabilities. Okay. So pure probability means simple. They will say like this, for example, probability of x3 equal to 2. Okay. Now just note it down. What is this 2 refers? This 2 refers the state. Okay. This 2 refers the state of the probability, and this number 3 refers the step or stage. So we know what is meant by states. The states, like at time t naught, it is the state is a naught, then a1, a2, etc., a3. So always this xn, this represents which step you are at, your, like in the problem, in which step you are going to proceed, step or stage. And this number xn equal to that a, because I said just now probability of xn equal to an. So this n refers the step and this an, the value refers the state, student. So now how to write like this? If it is pure probability, we will express this in small p. Remember, if it is pure probability, we express this in small p. Now you see step. How many steps we have? We have in the third step. Okay, we have to give notations like this. It's third step. And what is the state here? 2. So at state 2. So once you identify this thing, then from the problem you can get the probability. So remember, pure probability, when you find, always we use the small p notation, and the step will come in the power like this, and which state it is, we have to write like this. Okay, next. So to find this p3, okay, listen, the small p naught will be given to you initially. Whatever the problem is there, they will give you p naught. Okay, and they will give you a matrix, this capital P. This matrix is known as transition probability matrix. Okay, people simply say is a TPM. So this is the initial values given to you. So now how to find the next value? Suppose for the problem you need to find P3. So the formula is Pn is equal to Pn minus 1 into P. And remember, students, this Pn is always a row matrix. Okay, it exactly contains only one row and number of columns according to the problem, student. So if you want to find P3, first you need to find P1, and P0 is the row matrix given, multiply with this matrix. Then once you find P1, you have to go for P2. P2 is nothing but P1 into P. You have to iterate this till you get your desired value. I need 3, so you have to go for 3 times iteration. Clear, students? So this is the relation. So the proofs, all these things are not in our syllabus, so I'm just giving the formulae. So for pure probability, remember, pure probability is always small p, and this is my step and this is my state. Interchange, or if you choose wrongly, then the total problem get collapsed. Okay, you will be in second step and third state, the answer will be different. Now the next guy is conditional probability. I will also take one example. Probability of x equal to 1, x4 equal to 3. Okay, listen students. Conditional probability means you have to always represent in capital P. So this pure probability depends on this row matrix. It is a single row matrix. P0, from this we are going to find P1, P2, P3 according to the question. And the conditional probability will depend on this TPM, transition probability matrix, going to be n cross n. Okay, so pure probability depends on small p, and conditional probability depends on the TPM matrix, transition probability matrix, capital P. Just now I said for Markov's process or Markov chain, the future value depends only on the past value. Now you see, student, these two are steps and these two are state. Okay, now tell me, students, what is the difference between these two steps? What is the difference between these two steps? You should not subtract. Okay, you have to take the difference. 4 minus 6 is minus 2, but 4 different 6 is 2. Okay, so that means the same story here. For capital P, to avoid confusion, I'm not putting the bracket, I'm just putting 2. That means P square. How to find P square? It is very simple. You will be having a n cross n matrix. Okay, how to find P square? Just multiply the matrix 2 times. Okay, P square is equal to P into P. You know all matrix multiplication. Either you can do by manually or by calculator. If my step is 3, then you have to multiply 3 times according to the problem. Now this is done. Now you have to find the specific value. So now you have to see this thing. So remember, the future value depends on present value. So always you have to write like this, is because this is going to be a matrix. You are going to write, how can I say this? You're going to write Pij position. That means, suppose I'm saying P23 in the matrix, second row and third column. Okay, so now how to choose this? So the future value depends only on the present. So here, see, this is the present. So always the present value should come for row and the future value should come for column. That means you need to take the matrix, go to the matrix, square it and find the position 3, 1. That will give the answer for the conditional probability, students. That's it. So this is the notation 2. And third notation, sequential notation, is very easy. Suppose probability of x3 equal to 2, x2 equal to 1, x1 equal to 0, x0 equal to 2. Suppose I'm keeping like this. Now student, tell me, just now I said, if this is a future value, it depends only on what? This. Suppose if this is a future value, it depends on this. If this is a future value, it depends on this. At the end, this is the starting value. It does not depend on anything. Okay. So this is pure probability. It does not depend on anything. And here we are imposing the conditional probability. So how can we write this? If we have a sequence, probability of x3 equal to 2 given x2 equal to 1 into probability of x2 equal to 1 given x1 equal to 0. Then probability of x1 equal to 0 given x0 equal to 2. Finally, probability of x0 equal to 2, because it's the initial stage, it does not have any condition. So this is the answer, student. Now, how to find this answer? Because you see, conditional probability means 1, 2, 3. 3 conditional probabilities are there. So 3 capital P. And then there is one pure probability. So I am keeping small p. So my step is 0. So I have to see at state 2. In state 2, I have to see at step 0. So now this is, you see, all the difference here is 1, 2 to 3, 1 to 2, 1 to 0. So difference is 1. So P1, 1. That means P1 is nothing but the given matrix P. So now see the stage. Okay. See the stage or step. You see, this is 1 and 2. So 1, 2. This is 0, 1, 0, 1. This is 2, 0, 2, 0. Now you have to go to the matrix and then find these values and multiply. You will get the answer. Let us go to the problem so that you can understand very crystal clearly.